I've been walking these roads under stars and the rain, asking questions that
Welcome
circle,
back to Vibe
yet
Podcast
come
Conspiracy
back the
Club. Today
same.
we're discussing
Every
tracking time distance
story
of
I
arrival, a
hear
topic
holds a
researched
flicker
for
of
us by
you,
David Morgan.
but it
I'm
falls
joined
into
by Charles and Angela.
Good to be here, Alice. As a retired police ballistics expert, I'm always keen to look at the facts and clear away the noise.
And I'm Angela, an audio analyst specializing in acoustic reconstruction. I'm here to share how sound waves can tell a very precise story.
Excellent. So, let's dive into a truly compelling forensic puzzle we've been researching, the shooting of political commentator Charlie Kirk. The central question remains, was the gunman perched in the distant Luze Center, as the FBI claimed? Or, as new acoustic evidence suggests, much closer, somewhere inside the South Courtyard itself? Charles, the FBI's reconstruction put the shooter at the Luze building, about 130 meters away. From your experience, why did they land there?
Well, it's simple physics, really, Alice. The ballistic trajectory, the angle of entry of the projectile, and if they found the recovered round itself points to a downward shot from an elevated position. That's entirely consistent with a shot originating from, say, the roof of the Luze building. It's textbook external ballistics. Muzzle velocity, gravity drop, air resistance, everything fits a long-range Mauser hunting rifle.
And Angela, you found evidence that challenges this. A report you found uses something called time difference of arrival, or TDoA. Can you walk us through that?
Certainly, Alice. TDoA is essentially acoustic triangulation. When a gun fires, the sound propagates outwards and reaches different microphones at slightly different times. By meticulously measuring those microsecond delays, you can pinpoint the origin of the sound. In the analysis, using synchronized video and audio clips, all the timing corridors converge, not on the Luze building, but inside the South Courtyard, approximately 80 to 85 meters from Mr. Kirk.
But those were YouTube clips, weren't they? Highly compressed, lossy audio. I'd argue that's hardly forensic-grade evidence for something as precise as sound timing.
Actually, Charles, compression doesn't destroy transient timing in the way you might think. Even AAC or MP3 formats maintain sample clock precision, usually around 0.02 milliseconds per sample. While you might lose spectral detail and overall fidelity, the timing accuracy of key events, like a gun report, remains largely intact. As long as the clips share a common acoustic event, the timing holds.
So, even with compressed audio, the differences between arrival times, the TDoA, remain reliable.
Exactly. And the report verified this further by aligning the precise transient peaks, what you'd hear as the initial crack of the shot. Then, it delved into impact to bang timing, which is another crucial data point.
Right, that part truly fascinated me. The report measured the gap between the projectile's impact and the muzzle blast.
Precisely. Mr. Kirk reacts visually to the bullet's impact before the sound of the shot reaches any of the microphones. This tells us the bullet was supersonic. When we calculate that delay, which was consistently in the range of 80 to 160 milliseconds, it directly translates to a distance of roughly 50 to 95 meters. A 130-meter shot, like the FBI's Luze theory, would necessitate a much longer 214-millisecond gap. That simply wasn't present in the recordings.
Unless the reaction time estimate is off. Humans aren't stopwatches, Angela. Maybe he flinched later, maybe the video frame's sync was slightly lagged. Even small errors in those assumptions can blow that range wide open.
The report accounted for that, Charles. It factored in typical human latency between 120 and 200 milliseconds, plus a plus or minus 3 millisecond timing uncertainty. Even with those generous margins, the numbers still land squarely within the courtyard.
Let me quote directly from the report's executive summary for our listeners. Multiple independent acoustic measurements converge on the South Courtyard corner, approximately 80 to 85 meters from the victim. The Luze building reflections appear as late, higher-order echoes, not as the direct source. That's a pretty confident conclusion, Angela.
I'll grant it's a clever analysis, but reflections and echoes in an urban environment can be incredibly deceptive. Walls, glass, even crowds and trees, any one of those could easily skew your readings.
True, but the report cross-checked the data across 5 distinct microphones. The early reflections consistently came from nearby facades, at 38, 76, and 87 meters. The later echoes, at 103 meters, were what lined up with the Losi building, explicitly proving it reflected sound, rather than being the source of its emission. All the first-order reflections consistently pointed inward, not outward from Losi.
So the report's argument is that the directionality of these reflections actually proves the sound originated from inside the courtyard, not traveling toward it from Luze.
Exactly. The acoustic energy was moving toward Kirk, bouncing off walls behind him. That specific geometrical sequence simply cannot happen if the shot originated from Losi. The arrival sequence in the waveform would appear reversed.
Still, without a recovered cartridge, or verified muzzle flash evidence, we're talking entirely indirect evidence here. In traditional ballistics investigations, that's largely circumstantial.
And yet, Charles, audio forensics is physics too. When three independent measurements, impact timing, TDoA bearings, and reflection offsets, all consistently point to the same 80-meter sector, that moves beyond mere coincidence. That's compelling data.
Let me interject with a quick fact check for our listeners. At 30 degrees Celsius, sound travels about 349 meters per second. So, even a few milliseconds delay can mean meters of spatial difference. These analysts are truly measuring milliseconds to locate a shooter's position. It's incredibly fine-grained work.
Fair point, Alice, but my skepticism still stands. If we accept a courtyard origin, we also have to accept that every traditional ballistic trajectory analysis was fundamentally wrong. That's a significant leap for someone trained in established forensic methods.
Or, Charles, that the projectile path was perhaps misinterpreted because it wasn't analyzed within its full 3D acoustic context. The sound field tells a consistent story, a short-range shot, originating from the courtyard corner, not a long-range shot from Losi.
I think we can all agree that this case powerfully highlights a fascinating tension between traditional ballistics and emerging acoustic reconstruction methods. One deals with trajectories and physical mass, the other with precise time and waveforms. When both disagree, that's often where the truth truly hides.
Or, a third crazy explanation that none of us have considered yet.
Perhaps, but data, as they say, doesn't lie. People sometimes do.
That's all for today. A big thank you to our guest researcher, David Morgan, for locating our topic. I'm Alice, and this is Vibe Podcast Conspiracy Club. Until next time, stay curious, stay skeptical.
Every story I hear holds a flicker of you, but it falters and fades when it's missing the truth. For the truth you need proof, for the proof you need truth. Like the river needs stone, like the sky needs the moon. For the truth you need proof, for the proof you need truth. And the answers will come, though they never come soon.